Welcome to the first video in our unit on acids and bases. In this video, we're going to talk about the properties of acids and bases. We're going to talk about some common acids and bases that you may have seen before. We'll go over the definition of what an acid is and what a base is, and how those relate to a couple of ions that you may have seen before. And then we'll talk about the difference between a strong acid or base and a weak acid or base, and how they interact with water. Right, so if we go through some of the properties of acids and bases, well, if we think about how they taste acids, so things like citric acid, those candies that are based on acid, they all taste a little bit tart or sour, right? So acids have a very sour taste to them. Now bases, if you've ever eaten very dark chocolate, that's very basic. If you've ever had to bite a bar of soap growing up for foul language, that's also a fairly strong base, and those things tend to be very bitter, right? Bases have a very bitter taste to them. Now, the way that they feel when you touch them, acids, they feel a little bit rough, right? The reason why acids feel somewhat rough is because they're very corrosive to body tissue, right? Not only are they corrosive to body tissue, but they're also very corrosive when you place them on a metal. They'll react with a metal to produce hydrogen gas, right? So whenever you add an acid into a base or into a metal, a lot of times you'll see little bubbles come up, which is your hydrogen gas or carbon dioxide gas forming in the case of something like baking soda. Bases, if you touch them, bases tend to feel very slippery. And again, that makes sense, right? Soaps are bases and soaps feel slippery. The reason why bases feel slippery when you touch them is because what they're doing is they're actually taking the oils and fats on your skin and they're emulsifying them into a soap. Right? That's all lye soap is, for example. Right? Lye soap is you take an oil or a fat, you pour in sodium hydroxide, and it makes soap. Now, for the pH of an acid or base, you guys have known this since middle school, acids tend to be on the lower end of the pH scale, right? So below 7. Bases are higher end of the pH scale, above 7. If we talk about a common acid-base indicator called litmus, acids turn litmus dye red. Bases turn litmus dye blue. Right, so those are just some common properties that you'll see with acids and bases. So let's start getting into the definition of what an acid and a base actually is. Right, so an acid, simply put, is any substance that can give up, lose, or donate a proton. A proton is just a hydrogen atom with a positive charge. Right, because acids donate protons, their formulas tend to start with hydrogen. Right, so hydrochloric acid, HCl, acetic acid, HC2H3O2, right? They start with hydrogen. Now, when you take an acid and you put it in water, when the hydrogen or the proton is lost, that proton immediately finds a water molecule and forms what's called the hydronium ion, H3O+. So one of the things that you'll see me doing over the course of this unit is I'm going to use H+ and H3O+ almost interchangeably. Right? And just keep in mind that H3O+ comes about because protons, the instant they touch water, will form that ion. If acids donate protons, bases, because they're the opposite of acids, have to accept the proton. Right? So if you take a base and you dissolve it in water, what's going to happen is that it's going to produce the hydroxide ion. Now, hydroxide and hydronium are going to be the two ions that are most important during this unit. A solution's never going to be 100% acidic or 100% basic. You're always going to have some amount of both ions present. The difference is that acids have more hydronium ions than hydroxide, whereas bases have more hydroxide than hydronium. Now, because bases produce hydroxide, any metallic hydroxide compound will act as a base. So those are always going to be bases no matter what. But we're not just limited to hydroxides. There are a lot of other bases that we can work with, right? Things like baking soda is a base, bleach is a base, ammonia is a base. None of them have hydroxide in them, but they all still act as bases because they take the proton in from the hydrogen. Now, a way that we go about differentiating between different types of acids and bases is we differentiate between their strength. The strength basically measures how much the acid or base will break up when you put it into water. A strong acid or a strong base will completely break up when you put it in water. Right? So, to give you the list of the strong acids and strong bases, the strong acids, this list right here is what's commonly referred to as the big six. These are the only 6 strong acids we're going to work with: hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, and sulfuric. Right? If we were to take, for example, hydrochloric acid and put it in water, what's going to happen is that the hydrochloric acid loses the proton. When it does, we're going to be left with just chloride. And then that proton attaches itself to the water molecule, which is going to act like the base in this reaction, and it forms H3O+. Right? So those are strong acids. Strong bases are any hydroxide of a group 1 metal or a group 2 metal. So sodium, lithium, potassium hydroxide. All of them are strong bases. If you put sodium hydroxide in water, it will dissolve to form the sodium ion and the hydroxide ion. That's what makes it basic. Right, so strong acids break up 100% of the way, which is why, by the way, you see me writing the single direction arrow here. Weak acids and bases, however, will only break up partially, so less than 100%. The easy way to know if something is a weak acid or a base, if it's not on one of those 2 lists I gave you on the last slide, it's weak. Right? So any acid other than the big 6 is going to be weak. Any base other than a group 1 or group 2 hydroxide is going to be weak. And just to kind of show you the reactions between a weak acid and a weak base in water, we'll take, for example, acetic acid. Right? So acetic acid, HC2H3O2, we put it in water. What's going to happen is that the acetic acid will lose the proton, same as HCl did, and it's going to form the acetate ion and H3O+. Now notice the difference here. In the previous slide, I wrote the regular yields arrow because the reaction happens 100% of the way. Because this only partially happens, I write a reversible arrow. That's going to be the main difference between weak and strong, is which arrow we write. Right, so that's acetic acid. If I look at ammonia as an example of a weak base, I take ammonia, which is NH3, react it with water. What's going to happen is, because ammonia is a base, it's going to accept one of the protons from water. And when it does, that will form NH4+, and then the water is left with the hydroxide ion portion of it, OH-. Right, so the acid still formed H3O+, the base still formed OH-. We're just going to form a lot less of them. Right, so that's our introduction to acids and bases. In the next video, we're going to talk about the first of 2 reaction types, which is called proton transfer. Then we'll talk about the second reaction type in a further video called neutralization.